All right, so we're looking at standard deviation. And standard deviation is essentially how far things deviate or differ from the mean. And by the mean, we mean the average. So let's go ahead and just look at an example here. So the first step is to figure out what the mean is. So I need to add all of those values up. So 28 plus 14 plus 15 plus 19 plus 24, and divide by 1, 2, 3, 4, 5. So I get that the mean is 20. The range is just the range of values, so how far are we varying? So we're going from 14 to 28, so we subtract that, and we have that our range is 20. And then we need to figure out the standard deviation. So for the standard deviation, the first thing that we need to do is to figure out how far everything is from the mean. So 1, we calculate the mean. 2, we find out how far everything is from the mean. So that would be, what, 8? Difference between those two is 8, difference between those two is 6, and 5, and 1, and 4. So again, the first thing I do is just find out how far everything is from the mean. The next thing I do is I square them and add them. And that gives me, what, 64 plus 36 plus 25 plus 1 plus 16 is 142. And then what I want to do is I want to divide by how many I had. So I had a 5, because I do want to find what is the average of kind of what's going on here. So I find the difference from the mean. I square them and then add them. And then divide by the sample size. So I have 142 divided by 5, which is 28.4. Now, think about this. 28.4 is not the average of the differences. These are all the differences still sitting here right now, and the average is around 5-ish, somewhere like that. But if I square root that number, I get 5.33. So that is our last step. After we divide by the sample size, our last step is that we need to square root the answer. Okay, so that is how you find the mean. Now, some of the rest of these are important to look at, because none of the rest of these do you need to actually calculate the standard deviation for, because you're just trying to figure out which one has a larger standard deviation. So here, if I look at the range of values, we're going 6. Whereas if I look at the range of values here, I'm going 8. Both of these have a mean, or x bar, of 6. But these are 1 away and then 3 away, and these are 2 away and then 4 away. So these are all farther apart than these guys here, making B have a larger standard deviation. Things are deviating more from the norm. Here we have all of those numbers are identical. We have that our mean, our x bar, is equal to 15 for both of them. So we need to look at these guys here. This is 1 away and 1 away. This is 4 away and 4 away. So these guys here, when I do my standard deviation, will produce something that is larger. When I look at these guys here, plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. So my mean is different. My mean is bigger here than it is here. But in terms of the standard deviation, we want to find out how far things deviate from the mean. So if we look at it, we're 3 apart, 2 apart, 3 apart, 0 apart, 4 apart, 3 apart, 2 apart, 3 apart, 0 apart, 4 apart. Everything is dispersed exactly the same way with these numbers and these numbers. So I will not have a larger standard deviation. They'll be identical because, again, all of these numbers are all very evenly placed in exactly the same way. So 9/3.